Okay, so welcome, and today we are going to be looking at a tutorial for use with dplyr, okay, dplyr, and also tidyr. Okay, these are two packages that we'll cover today, and this doesn't, in terms of the topics that we're covering, it's not like it fits in nicely. It's kind of like here's a side note, here's some important stuff that you should know, but it doesn't quite flow in with, in 102 we're talking about, well, I guess it kind of fits in terms of like getting data into R. And then in 101 we're talking about diagnosing, model diagnostics and making sure that you have the appropriate fit. So, this doesn't quite fit in that current schedule, but it is important, and I wanted to cover it because a lot of your time, in our classes, I try to set things up nicely, or we have these data files that are easy to work with. And so we've got that going on, but a lot of times the data that you get is not super nice to work with, okay? And so I want to start off, if you go into CCLE, you'll see I have a few data sets that you can put into R. We've got the storms, the cases, and the pollution data set. So this part we're going to start off with tidyr, and if you haven't done so already, load the packages tidyr and dplyr, and so you can always do that using install.packages quote tidyr, and then you would do the same thing for install.packages quote dplyr. Okay, so if you haven't done this already, go ahead and run those commands, and I hope your mirrors will allow for the installation. And then after you install those, go ahead and load those libraries with library tidyr and library dplyr. Okay. And then again in CCLE, I kind of just have this that says some of the data used for tidyr and dplyr. This is a few of them right here. Okay. So let me back up a couple of slides here. So this I can't claim credit for this tutorial here. The people at our studio, Garrett Gromland in particular, put this presentation together, but it's a very good one. So why reinvent the wheel? I will present it to you guys, muchly in much the same form he has presented it. Okay, so are you guys able to get these data sets into R? Okay, everyone's good, or anybody having not there yet?
I cannot load one of the packages, tidyr, for some reason.
tidyr. What error are you running into?
Well, it says just warning and install packages. Package tidyr is not available for R version 3.0.2, and that's like the latest version.
Let's see. Come over here into the lower right-hand area where it says packages, and then it'll do its thing, and then search for tidyr. You can and then no, it's not there. You might need to change your cran mirror, but I don't remember how to do that.
Well, I guess we'll just watch for now.
Okay, I'm really sorry. Okay, maybe there's an option to select your cran mirror in our studio. Let me see. global options. So if you go to global options, you can, under packages, under Cranmere, you might be able to change it to something like USA California 2, which is our campus, or the UCLA, California 1, or whatever you want. Okay, you might be able to change mirrors, and that might solve the problem. Okay, I'm not sure. Okay, but let's go ahead and take a look at some of these things. If we just look at storms, we see it looks like this. If we look at cases, it looks like this. And if we look at pollution, it looks like this. You guys are all with me so far? Give me a nod of the head. Okay, so we're good. Okay, so then, if we look at the data sets, we got stuff that looks like this. Okay, so this is kind of just formatted nice and pretty. Only one of these data sets is formatted in the way that is conducive for data analysis in R, okay? And that would be the storms data set, where each row is a case and each column is a different variable, okay? And so, if we look at each column, we've got the storm name, the wind speed, the air pressure, and the date, okay? So each column in storms is a different variable, and we can, and each row is a case. So this is the way we want things in R, and this is what Hadley Wickham refers to as tidy data, okay? Tidy data meaning each column is a variable, each row is an observation or a case that we want, okay? Over here we're looking at, I don't know, some kind of disease, cases of disease, okay? But what are the variables? We've got the country, okay, and then we have the year that we recorded data in. So we've got the country of France, Germany, and America. Or I guess it could be Denmark, but I'm assuming this is Germany. And then we've got the year, 2011, 2012, 2013. But the data is stored in this area. So we're looking at the count, France in 2011 had 7,000 cases, and 2012 had 6,900 cases, and in 2013 had 7,000 cases, and the data is presented, the actual counts that we want are right here, okay? And so, when you're pulling data from different sources, you might get things in this form, okay? And then if we look at pollution, we've got different cities. We've got New York, London, and Beijing. And then it says we're looking at the particle size. You got large particles and small particles, and then we're measuring how much we have, okay? And so we've got, New York had 23 micrograms per cubic meter of large particles and 14 micrograms of pollution in small particles and things like that. And you go to Beijing and you got a lot of pollution for large and small particles and things like that. But what are the variables in this data set? Okay, so we have the city, and we have the amount of large particles, which are these rows. Okay, so the now white rows, these are the amount of large particles, and we also have the amount of small particles, okay? So we have the data stored in kind of an odd, odd form here, in that, if we wanted to kind of just take the difference between large and small particles, it would be a little bit troublesome to do that in this format, okay? So can we see the differences between the way the data is stored in these, quote, raw tables? Is that good? Okay, so tidyr helps us turn all of these different data sets into kind of the tidy form. So when it's in tidy data, you can just use $sign notation and refer to each column, okay? in the other forms, you'd have to use some, you know, R acrobatics to try to get the data that you want. Okay? So again, when it is in tidy form, you can just do things like, let's calculate the ratio between wind and pressure. And all we have to do is we just do this divided by this, and it gives us a value. Okay? So, you know, I'm not sure where these numbers came from, but you know, it's very easy. We just do storms, $pressure, so it would be 1,007 divided by 110, and it spits out a value over here. So it's very nice, okay, when they're in tidy data form. Okay, so again, here's a summary of what tidy data should look like, and this is how we want the R data in R to look. Okay, questions on any of this so far? We're all good. Okay, so again, you know, if I come down here to storms, I can do storms, $pressure, divided by storms, $wind, okay? And we see that it calculates all of these things, okay? And then I could easily just, you know, add this to a column and create a new column in storms using this, okay? And we'll show you how to do that. Yes, question?
If you do tidyr on the pollution, how would the data look like?
Tidyr and pollution, yeah. So let's I'll show you, okay? But we'll get to that after we handle the cases table first, and then we'll do the pollution table. So we'll show you how the tidyr data should look. And there's also, you know, some of this is you have to ask, how do I want to analyze this data? And so what one person considers tidy data, somebody else might actually want to do some modifications for their version of tidy data, okay? And it all depends on how you want to handle certain variables, okay? And so we'll take a look, okay? The tidyr package allows you to kind of make these manipulations as you see fit. Okay. So anyway, tidy data is good. Okay. So anyway, you can install package tidyr. Okay. And the two big functions that we will use in tidyr are gather and spread. Okay. These are going to be the two big functions that we use in tidyr to kind of reshape the data that we want. Okay, so this says, imagine how this data would look if we were to tidy the three variables country, year, and count. So these are our three variables, country, year, and count. How should this look? Okay. All right, so, well, how many columns will our final data set have? 3, right? In tidy data, each variable has its own column, okay? So then, how many rows will our final data set have? Our final data set should have 9 rows, okay? We're going to have 3 rows for France, 3 rows for Germany, 3 rows for the US. Each row for France will be one of the years, 2011, 2012, and 2013. So you know, if we do this, we'll start off, we're going to have 3 columns, and then one of the rows will be France in the year 2011 had 7,000 particles, or no, 7,000 cases of whatever disease we're looking at. In 2011, Germany had 5,800 cases, and in 2011, the U.S. had 15,000 cases, okay? Whatever this is, okay? And so we can go through, and so our final table will have 9 rows, and this is what tidy data in R should look like, okay? Is everybody okay with going from here to here? At least in our heads. We have to understand what we're doing in our head first before we understand how to do it with the computer, right? So, are there any questions on how tidy data should look like at the end. Yes, question?
So in this example, it grouped all the years together, but you could also group them by country, right?
Yeah. So once we get it into tidy data, we can sort however we want. Okay, we can sort them however we want. In this example, yeah, they kind of sorted or sorted by year, but yes, we could sort however in whatever order we wanted here. Okay. All right. So the command we're going to use in R. So this is to show each column has its own thing. The command we use is gather. Okay. So if you've got data in separate columns and you want to put them into one column, the command you use is gather. All right. And what we're doing is we're going to take these numbers, 7,000, 5,800, 15,000, okay, and we're going to use the column heading 2011 as kind of the indicator of what the value year should be. Okay. So we're looking at this, and we look at the column heading 2011, 2012, and 2013 as our key, okay? These are the column names, and we're turning them into the key to say, okay, it's not just France 7,000, it's France in the year 2011 had 7,000 cases, okay? And these values over here, these become our value. So what we do, okay, is there are, so what gather does is it takes multiple columns and it collapses them into two columns, okay? So it took these three columns, and if I had, 2014, 2015, 2016, whatever, I could take, 20 columns as long as they all had the appropriate headings, and it would turn them into two columns, okay? So gather takes a bunch of columns and it turns it into two columns. One of them is going to be the key, okay, which is the former column names, and the other one is the value that we want, the values in those cells, okay? And so when we write our gather function, okay, the first argument in the gather function is the table that you're using, okay? And then you name the two columns, okay? These are just the names. These are not, they're not looking at, it doesn't understand what this is just a name, and there's no inherent meaning to this. If you wanted to call this yippity-yay, it would take that, okay? This is just the name of the two columns. So this is, the first one is going to be the name of the key column, and then the second thing is the name of the values column, okay? So if you wanted to call this values, that's fine. It's just the name. There's no inherent meaning to these things that we've selected here. So if you wanted to call this X or values or whatever it is, we can do that, okay? And then you tell it, once you do that, you say, okay, then do this thing based for columns 2 through 4, okay? So if we go back to our data set, cases, we want columns 2, 3, and 4 as the ones to gather. Is that okay? So before you can do that though, however, if we look at our cases table, for whatever reason, it has stuck this letter X in front of it. So if we gathered it right now, the value that shows up in our key column, which we're calling it year, will have X 2011, X 2012, X 2013, which is probably not what you want, okay? So what I'm going to do is I'm just going to change the name of cases, okay? So I'm going to say take the names of cases, right? So if I ask what are the names of cases, it says you've got country, 2011, 2012, 2013, okay? So I'm going to just say, you know what? I want to rename them to country and then 2011 through 2013, okay? And over here I said as.character, but if I do this, will this work? And the answer is yes, because R will coerce 2011, 2012, and 2013 into characters anyway. So can you guys see this? Okay, so then if I ask, let's take a look at the cases table now. We see, okay, it worked. And it renamed it from X 2011 to X 2012, X 2013. Okay, and so let's run this gather command. Okay, so we're going to gather the cases table, and again, you can call it whatever you want to call it. So it could just be year, capital or lowercase, however you want it, and then we can call it n, or we can call it cases or value, whatever you want to write. And then you say which columns are you going to gather. So we tell R gather columns 2, 3, and 4, 2 through 4. Okay, and when it does that, it turns it into tidy data for us. Okay, are you guys able to do it on your own computers? It's pretty neat, right? Okay, and so you can now save this. Okay, so when you run the command, it doesn't, it has no side effects. Okay, it doesn't change anything else. So if you want to save this, you have to now create something, an object. You can call it cases, or you can call it, tidy cases, whatever you want to call it. And we're going to take this thing, okay. And so now I have the ugly cases, and now I have the messy cases, and now I have tidy cases, okay? And then so now with tidy cases, we can do whatever $ analysis we want, tidy underscore cases, and we go to value, and it does that, or tidy $ cases, year, and we have that, things like that, okay? And we can with deploy or whatever, we can filter or subset based on year, subset based on country, or things like that. Okay. Questions? I see some confused looks, so I just want to make sure we're okay before I move on here. No questions? Okay, yes, question, thank you.
Automatically coerce like the value that you're going to put, like the first value of the year, the thing that you're taking from like the columns to rows, always going to make it a factor, or will sometimes not be? Like the type of case is year.
Yeah, that is a good question, and I want to say it makes it a factor always, but here, we'll ask for help on gather, and we'll see what it says. According to my viewer. Okay, so I guess there's an option called convert, and it will okay, so you can okay, so I guess one of their names, their character, now I'm these are intrinsic small details that I'm not entirely sure about. So there is an option to convert the key column into values or something, which I'm not 100% sure. It runs a type.convert convert something here. So apparently you do have some control over this if you need to. In the worst case scenario, you just run it with the defaults, and then you do type of tidy $year, and you're like, oh, I actually want it, I don't want integer, okay, or it's actually a factor, right? So you say, oh, you know what, I don't want this as a factor, I want this as something else. So then you could, if you needed to, you can do tidy underscore cases $year, and you can say as dot numeric, and then I think we'd have to do as dot character first, character tidy $year, okay? Oh, not tidy year, tidy $cases. Okay, and then if I look up tidy cases $year, then it's just a numeric vector. Okay, so you can always do the manual conversion yourself later if you need to. Okay, but anyway, so that is the gather function. Okay, so you have data stored like this, and you want to turn it into tidy data, where rather than having 2011 show up as a column and 2012 show up as a column and 2013 show up as a column, it turns it into row pairs like that. Okay, and so there they ran it and it worked. Okay. Okay, so here's the question that was asked earlier. That was, what would the pollution data look like if we turned it into tidy data? Okay. So again, what are our three variables? We've got city, and then we've got large particle pollution and small particle pollution. Those are our three variables. Okay. So how many columns will our tidy data have? So our tidy data will have 3 columns of data, right? And the 3 columns will be city, large pollution, and small pollution, right? That's not a trick question. It's just in tidy data, whatever your variables are, each variable is going to have its own column, okay? And then, so over here, we have it like this. What we want then is we're going to have different numbers. So how many rows will I end up having in this tidy data set? I'm going to have 3 rows, 1 for each city, right? So if we turn this into tidy data, I'm going to have large pollution particles from New York, and then small pollution particles from New York. Large pollution particles from London, small pollution particles from London, large from Beijing, and small from Beijing, okay? Whoops. And so this is what my final tidy data in R is going to have. I'm going to have 3 rows and 3 columns, okay? So is the conversion from this thing into this thing okay? Okay, again, we have to understand what we're doing conceptually before we understand what's happening on the computer. Okay. All right, and so the function we use here is called spread, because we are taking basically this value, the column amount, and we're spreading them into 2 columns, okay? Or however many columns you need to spread them into, okay? So what it's going to look at, so you can think of spread as kind of the reverse of gather, okay? What it looks at is it looks at this column's size, and it sees there are 2 different key values. We've got large and we've got small, okay? If we had, large particles, small particles, and I don't know, medium particles, or however we wanted, okay, then each city would have 3 lines, right? Large, small, medium, large, small, medium, large, small, medium. And then when we apply spread, it would spread it into 3 columns. So tidyr kind of automatically looks at this thing and says, well, how many different key values do I see? And I'm going to create a column for each one, okay? So the values that we want to store is in the amount column, okay? So what we do here, okay, is we say take the data frame or data set pollution, and then what I want is look for the key values in size, okay? So now it matters, we're not giving it names, okay, we're telling it, it does matter, and it says, so look at the size column and find unique keys in the size column, and then the values that I want you to store are held in the amount column. Okay, so we give it the data frame, the column to use for keys. Okay, these are going to form our new column names, and then these are the column to use for the values here. Okay, and this is the spread function within tidyr. Is that good? Okay. And then so if we apply that to our data set, so let's take a look at pollution. Okay, so we see it written like this. We want to take the size, so we're going to do spread pollution, and look at the size column, and the values that we want you to store are in the amount column. Okay, and when we do that, it says, oh, I find the word large, and so it's going to create a column large here. Okay, and I see the value small, and it's going to create the column small here. Okay, so if for whatever reason in our pollution table, so that is spread, okay, and I can now store this as, you know, tidy pollution. It's kind of a oxymoron there, but let's say I added a row here, okay, or let's say I changed pollution, the 6th row, 2nd column, and let's say I gave it a capital small, okay. Okay, so I guess it says it's a factor. So let me pollution $size. We're going to as dot character pollution $size. Okay. Okay, so notice here now I have capital S small here. Everything else is the same. Okay, and let's run our spread command here. Okay, so it goes down the spread column and it says small. Okay, I see these different values, but then it sees capital S small, which is different, and it says, oh, I got to make a new column here, and it puts it over here. Okay, so when you apply spread to something like pollution, you got to make sure that the values that you're going to use for column names are consistent across all data. Otherwise, it will say, hey, Beijing doesn't have small s, small pollution, so it gives it an NA. But it says it does have big S, small pollution, 56, but the other cities don't have big S, small pollution. Okay, so just a warning here. Okay, yes.
So what if you had data that had numeric levels? So you had like a code that was like 1, 2, 3, 4.
Yeah, you could do that too. Okay, so let's here I'll do pollution. So let me just change this back to little s small. Okay, let's look at pollution. Okay, so I'm going to do pollution $small, and we're going to do as.factor. I'm sorry, pollution $size. Thank you. See, yeah, I gotta. Yes, thank you for doing that. Okay, so now we look at pollution, and it looks the same, but and now I can turn. Now that it's a factor, I can do as.integer. Okay. Okay, so I got 1, 2, 1, 2, 1, 2, 1, 2, right? Okay, so then we just apply the same command, pollution size amount. We're going to spread it, okay, and it works just fine, okay, just fine as well. Except because we got rid of the names large and small, it doesn't know what to call it. It just says, okay, here's 1 and here's 2. There you go, okay, and then you're going to probably have to. Just for your own sanity, you're going to probably want to rename these columns to what they actually stand for. Okay. Okay. And it's probably best if you have something like size 1, 2, 1, 2. It's probably best, if we got pollution looking like this. It's probably best to say, okay, pollution $size. We want to do factor. Pollution $size, and you specify the levels, and you say, well, 1 is the small, and 2 is the large or whatever it was, okay? And then so you probably want to do that. Oh, what did I do? Am I using my no, I have to do as.factor. Shoot, okay. Now that but I screwed it up now, so okay, give me a second here. So I have to do repeat 1, 2, 3 times. Okay, let me just make sure. Okay, and then we want to do, I think, as.factor. Why is this not working? Okay. Solution $ size levels small and large. Okay. Well, I don't know how to turn something into a factor right now. Okay, I'm just running into some hiccup here. But anyway, you probably would want to turn it into a factor and then split it out that way. But it would work. Okay. Okay. All right. I guess you can just do a lookup table, solution $ size. There's always multiple ways to solve a problem here. Lookup table where you'd say 1 equal to small and 2 equal to large. And I think this will do the trick too. No, it doesn't. Okay. Well, no, I'm embarrassed. Okay. Oh, because I screwed up earlier. Yeah. Okay. So now if I do this, no. Okay. Okay. Well, I'm doing something wrong. So. Oh yeah, I know what I'm doing. Okay. I should just humble myself and say, okay, I got it wrong, and move on. But but this is how you would do it. Okay, so yay. Okay, so you could do it that way. But anyway, you would use spread that way. Okay. Are there questions on this tidy data stuff? Okay, so yeah, if you have something like this, you can use the function spread to go this way. And if you see something like this, but you actually want it in this form, you can use the command gather. Okay, so spread and gather are kind of the, I don't know, anti-functions of each other. And depending on how your data is presented, maybe you want this form, or maybe you want this form. And it all depends. And tidyr gives you tools that you can change from one to another. And in an easy, I think relatively easy form, as long as you account for things having different spellings, capital S and small s and things like that. And you do have string functions. So let's say we have, if I do pollution $size is equal to this thing, okay? So we got pollution looking like this. If you had to, there are functions. I think they're like to upper and to lower. Let me just make sure. Yeah, so you can do things like to upper. So you take pollution $size and you do to upper, and it'll put everything in the same case. So you can eliminate these types of problems, or you can do to lower, same type of thing. Okay. So if you've got text files that you're working with, these are useful functions as well. Okay, so that is it for tidy data. Oh, there's unite and separate. So let's say you wanted to take this date column and then split it up into year, month, day, or something like that. As long as your data has some kind of separation character, you can do that as well. Okay. And so I'll post a link to this this presentation created by Garrett that is good. Okay, so you've got separate, which splits out the columns, and then if you want year, month, day to turn into a date, you can use unite. Okay, so you've got these functions that work in tandem. But I think the big ones are going to be spread and gather, or gather and spread. Probably most, gathers very nicely. Okay. All right, let's talk about dplyr. Okay. So dplyr is another library. Okay, and let's take a look here. And I think I've posted this introduction here. So Hadley wrote this introduction here, and he says, when you're working with data, first you got to figure out what you want to do and describe those tasks in the form of a computer program and execute what you want to do. Okay, and he says that dplyr makes this easy by giving you a set of verbs. Okay, and we'll talk about each of those verbs in a moment here. But let's say we want to the data set that we're going to deal with is called New York City Flights 13. So this contains all, there were 336,776 flights that departed New York City in the year 2013. And this data table contains all of them. Okay, and so you can load that. If you've got dplyr installed, it installs this package as well, and you just have to load it into memory by saying library New York City Flights 13. Okay, so that should load it into memory, and we can take a look at the flights here. Okay, and with dplyr, it is already in what we call tibble form, okay, not data frame. So if we just look at the flights table, which is just, we just type in flights, it automatically stops after 10 lines, okay, and it also shows you the variables that don't fit on screen, okay, whereas if it was in just a regular data frame form, it'll try to print the entire data frame, which can be annoying. Okay, so tibble.df or tibble_df is a nice, it plays nicely on your screen here. Okay. So then, we can. Just like with a data frame, you can ask what are the dimensions of flights. Okay, and it says there's 336,776, etc., etc., etc. Okay. All right, so these are the verbs that we can work with in dplyr. And there are more verbs, but these are probably the key ones. Okay. We have filter, okay, which is kind of like subset. You can think of filter as an alternative to subset. You've got all of 336,000 rows. You want to filter out or subset just to the rows that are of interest to you. Okay. You have a range, which then sorts those rows. Okay. So a range is used to sort the rows. And then you have, so these two, filter and range, work on the rows. And then you have select to select columns, okay? Distinct will select unique rows within a certain field, okay? So let's say, in our 336,000 rows, you know, these are all the flights that took off from New York City, we can look at what destination airport they had, okay? And if we just say, you know, let's look at the destination airport, it's going to give us back 336,000 rows or destination airports. But we can say, make that unique, okay? And then it will say, oh, there's, you know, 100 airports that these things went to, okay? We've got mutate, okay? Mutate is kind of a funny word choice in my opinion, but what this does is it takes your current data and then it creates a new column based on that, okay? So you're adding a new column to the thing. So let's say you wanted to figure out the, I don't know, flight duration. You can do arrival time minus departure time or something like that to figure out your flight duration. So that's that we'll be using mutate. Summarize takes a bunch of rows and it summarizes it into one number. Okay, so just like you think of your summary statistics like the mean or the standard deviation or anything like that, you're giving it a whole bunch of numbers and you're summarizing it down to a single number. Okay, you've got sample underscore n, which can be used to randomly select rows out of your table. All right, and then once we master these verbs, we can add great power to our tables to this by using this group by function. Okay, which does some really cool stuff. Yes.
Distinct function?
Yeah.
So, remember we had a table where, I don't know, New York or something, we
Yeah.
had small, big, small, big.
Yeah.
So the second column, we have like two distinct values, but in the first column, we have it for the same city.
Yeah.
We keep both rows or
So you have to use distinct with a select thing, okay? So you can't, you know, because if I just did distinct on the whole table, every row would be distinct from each other, right? But then I would say, okay, looking at the column particle size, tell me what's distinct in there, okay? Okay, yeah. Okay, so let's look at filter. This is very much just like if you guys used the subset command in R. It's very much like that, except you can apply multiple criteria, and you just have to separate them by commas, okay? So you don't have to say subset based on this, and sign this, and sign this. You just say comma, 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 and it automatically kind of assumes you want all of these things. So let's say we wanted to subset flights. We can just do flights, or I'm sorry, filter, okay? And what do we want to filter? We want to filter our table flights, and we can say where carrier equals UA, and you know, maybe we want for the month equal to January, and day will be January 10th or something like that. What did I have? Oh. Okay. So you do that, and then we got, you know, January 10th, United Airlines, okay? Or UA, whatever UA is. Pretty sure it's United. Okay. Continuing on here, maybe I'll, here, I'm going to put a